Let's start our question number 6 from the SD sheet. Hello everyone, welcome to our channel, which is Code with Sallu. And you guys won't believe I've been recording this video for the fourth time since in the previous videos there was a lot of background noise due to which I made it private. And now I am recording it again. So I wish I can explain you properly. So let's start the video. Uh, yes. Last time in the previous video, we had done this question using the linear search, which was taking O big O of n complexity, right? We were just simply traversing from 0th index to the end of the array and comparing if it's equals to the target and returning that index. Otherwise, we were returning -1, right? Let's do this using minus search so that we the search time complexity reduces to log of n, right? Hmm. So the template of binary search contains int. We declare the uh, starting point, which is 0, and then we declare the end, which will be nums dot then -1 end index, right? And then we are going to start our condition for the binary search, which is while s is less than equals to n, we will be moving our search space, reducing it to the half of the length, right? So yeah, now we will see if now we will declare int mid, right? Mid is equals to starting plus end by 2. Right? Okay. So this is there 0th, first, second, third, fourth, fifth, sixth. 0th index is 4th. 0th index is having element 4. 6th index is having element 2. So we know that it is sorted, but we also know that it is rotated around 4 times, right? 4 index, every index has been rotated plus 4, right? I mean, 0 was here, and 0 has moved to 0, 1, 2, 3, 4, right? Let's start doing this question. Now, if we will check first if mid is equals to target, then we are going to return target, right? I'm doing not target, it's return mid, right? Yeah, I meant that if we had to search here, not 4, um, not 0, we had to search 7. So suppose if target was 7 and 6 plus 0, which is 6 by 2, which is 3, 0, 1, 2, 3. So 7 will be in the middle, right? So the middle will be the target, right? So on the first condition, we are returning it, right? Uh, right, okay. Now we are going to start our binary search, which is not while if bracket. Now we are going to reduce our search space, which is if nums of s is less than equals to nums of wait, it's not equals to yeah. So we are first finding that we are checking if the left part of the array is sorted, which is from 0 to the mid, which is this one. On the first travel search, this will be our mid and this will be start, right? So if s is less than equals to mid, it means we have got this sorted part. Now the left side, we will start searching here, right? And now we will see if is lying here. Inside this, if nums of s is less than equals to target, okay, and target is greater than or equals to nums of mid, right? Wait. Ah, ah. If nums of, I mean, this part is sorted, we are going to search if 0 is here, right? No, if the target is here. Now let's say start implementing minus search in the first half. We will do what is. So if our target is lying over here, we would be reducing and is equal to mid minus 1, right? Yes. And is equals to mid minus, wait, and is equals to mid minus 1, right? Otherwise, you would have made s is equals to mid plus 1. Yes. If this part was not the case which was having a target, we would be moving our starting index to here so that we will search here, right? Which is true. We will be searching here because 0 is lying over here, right? On this fourth index. This is done. Now, when we have found that else part is here, else, yes, that is just else if nums of s, no, there is not s, there will be mid. If nums of mid is less than equals to target and if nums of and wait, wait, यहाँ if नहीं आएगा, here it will be not if and nums of target greater than equals to. If target is lying in the right half, right? Just true for this case. Target is lying on the right half. If mid is less than equal to target, hmm, currently not in this case because currently mid is 3. But we're thinking about hypothetical case when the loop has run for second, third time, right? If nums of mid is less than equal to target and target is greater than equals to nums of end. Simply this is saying that target is lying between here, between these two, right? These and this. If this is not the case, right? So, what we'll be doing? We will do s equals to mid plus 1, right? Otherwise, also will do which is n is equals to mid minus 1, right? Now these 1, 2, 3, 4, 5, 6. These if else cases will handle all the possible types of cases, right? Now let's return minus 1 if nothing is found. Return. S is less than equals to mid. Hmm. S is less than equals to target and target ये टारगेट जो है एस से बड़ा है. एक मिनट. नहीं यहाँ here it will be lesser than, right? Times it happens. So this is our uh, solution. Let me write the comments. While the while the binary search is not finished or covered all poss- possible hmm, possible possibilities, right? So this is the main condition for binary search. And this if case says if our target is in if left left half is sorted, right? And now this condition says if our target lies in left, we are reducing our space by half. And this is simply the else case. And this case is that when the left half was not sorted, I mean somehow when the S has lied, S and mid have got the index values which are not having the sorted part, right? In this case, and this is a similar case, similar. If target could write if not found, wait, okay. If not found, return minus. Like, let's stop the summon this first, right? With returning -1. Mid is less than target. It will be smaller, right? Sometimes this happens with me, but it's because big issues in future. So thank you for being with me in this video. Let's end the lecture.